June 18, variant 2. Um, Easy exam. A student investigated the rate of respiration of yeast at two different temperatures. Since I'm trying two different temperature, therefore the changed variable here will be the temperature. Okay, as we said, since we are trying at two different temperatures, therefore here the temperature will be the changed variable. The students provided with yeast suspension, which also contained glucose. The two identical sets of equipment were set up. These are the two identical sets of equipment. Since you put 5 cubic centimeter of yeast in both test tubes, in both you put the same volume, therefore this is a controlled variable or a constant variable, something you kept constant. One set of equipment was placed into warm water bath, as we said, and the other, the temperature was 50 degrees. The other was placed in a cool water bath. The temperature was 25 degrees. Okay? Volume of water in each water bath was the same. The volume of water was the same. Okay. Of course, any water bath you have that is not maintained, this is a source of error. Here, the temperature will not stay 50, and here it will not stay 25. It will either cool down or get hotter according to the surrounding room temperature. So this is a source of error that the temperature is not maintained. It is not constant at this level. It will definitely change. The student counted the number of bubbles. Number of bubbles, this is the results. Number of bubbles of gas produced by yeast suspension in 5 minutes. Counting the number of bubbles is inaccurate. It is another source of error because counting the bubbles may be too fast. You cannot see them. Also, the bubbles are not the same size. So this is another source of error in case he asked me. These are your results. He gave them to you in tally. This is how we count in tally. 1, 2, 3, 4, and we cross them. This is 5. So here 5 and 2, 7 bubbles. Here 5, 10, 15, and 4, so 19 bubbles. Okay. Prepare a table and record the results. We agreed that any table, changed variable is on the left, changed variable is on the left, and the results are on the right. So in this case, the changed variable is the temperature, which he gave me, 50 degrees, 25 degrees, and the results are the number of bubbles. Number of bubbles, which is 19 in the warm temperature, 7 in the cold temperature. Okay. At the end of the investigation, the final temperature of the water bath was measured. He gave you a thermometer and he wants you to record the final temperature of the water bath. At the beginning, this one was 50 degrees and this one was 25 degrees. At the end of the experiment, this one reached 43, this one reached 21. So he gave you a table and he asked you to complete the starting and the final temperature, 50, 43, 25, 21. Okay. State a conclusion for the results. Where do you get the conclusion? From the numbers in your table. As we can see, as the temperature increases, the number of bubbles increase, which means that the rate of respiration of the yeast is higher. As temperature increases, rate of respiration increases. Okay. Because of course the enzymes of the respiration works faster. Counting the number of bubbles may not produce an accurate method of measurement. As we said, counting the number of bubbles is inaccurate. Why is this? Because size of the bubbles are not equal. Sometimes it can give you 3 bubbles like this, others can give out like this. If we compare these bubbles to these bubbles, we cannot say that they are the same volume of gas. Definitely the bigger bubbles have more gas. So counting number of bubbles are inaccurate way because they are not all the same size. Also, they may be too fast to be counted. How do we improve this? How do we improve it? Collect the volume of gas using a gas syringe. The volume of gas coming out, you collect it using a gas syringe. Okay. Identify a variable that should have been kept constant but was not. He gave you a hint. He gave you that the temperature was 50, but then it cooled down to 43. The other one was 25, it cooled down to 21. So the temperature was supposed to be constant at the number you adjusted it to. However, it cooled down. So what is the variable? The temperature of each test tube. How can it be kept constant, Bab? How do you make it stay where it is? Using thermostatically controlled water bath, you will adjust 50 degrees and it will stay at 50 degrees. You will adjust 25 degrees, it will stay at 25 because it uses electricity to heat the water. Okay. What is the independent variable? The independent is what you changed. I changed the temperature. One time I put it in warm water bath, the other time I put it in a cool water bath. Dependent variable is the results. What were your results? Well, how were you measuring your results? The number of bubbles. The scientists investigated the effect of different concentrations of glucose on the rate of carbon dioxide. We tried different concentrations of glucose. Therefore, we have another changed variable here. We are going to change the concentration of glucose and check what happens to the rate of carbon dioxide production. They measured the volume of CO2 produced by yeast cells in 5 minutes. Before starting the investigation, he did a trial with one concentration of glucose. He tried one concentration and collected the volume of gas, but he did it 3 times. 3 times. He asked me to calculate the average number of carbon dioxide, the average volume of carbon dioxide produced in 5 minutes. How do we calculate the average? We add all the numbers together, sum of the data over their number. So all of these added over 3. All of these added over 3. It will give me 13.6. This is the average volume produced in 5 minutes. And then he asked me, can you calculate the average volume per minute? 1 minute. If it gave you 13.6 in 5 minutes, how much CO2 will be given in 1 minute? I'll just divide the 13.6 over 5 and it will give me 2.7. 2.7 cubic centimeter. Okay, the scientists performed their investigation. Their results are shown. As a rule, the independent variable on the left side is placed on the x-axis. The dependent variable on the right side, which are the results you are measuring, is placed on the y-axis. The first step is to put the labels. Put the labels on the x and the y. Plot a graph, include a line of best fit. Plot a graph and include a line of best fit. Okay. Since the numbers here have equal interval, we can start and put them as they are. 0, 0.5, 1, 1.5, 2, as they are on the x-axis. What about here? You have from 1.3 till 4.4. So if you're going to put a scale, your scale should cover from 0 to 5. Let's say from 0 to 5. This is what I did. 0.5, 1, 1.5, 2, 2.53. You can still start from the 0. It will be 0, 0.5, 1, 1.5, 2, 2.5. Okay, so you'll have an empty box at the beginning instead of at the end. Still correct. Okay. On the y-axis, we put the average rate of carbon dioxide. You have to write the full label with the unit, and I put my scale, and then I start plotting the points. At 0.5, it was 1.3. So this is 1, 1.1, 1.2, 1.3. At 1, it was 2.6, and then 3.8. And then 4.4, 4.3, 4.4, 4.4. This is how my points looked like. It looks like a curve. And as we said, when he asks you for a line of best fit, If the points are scattered like this, but they are all increasing, so we put a straight line in the middle using our ruler, passing through as much points as possible with equal points on both sides. However, if the points looks like a curve, it's increasing and then it levels off, we make a smooth curve using our hand. This is the best fit line here. This is the most suitable line in this case. Okay. Describe the effect of glucose concentration on the rate of carbon dioxide production by the respiring yeast cells. Describe the graph. As the concentration of glucose increases, from 0, let's say from 0.5 till 2, the average rate of carbon dioxide increased from 1.3 to 4.3. With the unit, please. You have to use the unit 1.3 cubic centimeter per minute to 4.3 cubic centimeter per minute. Okay? And then it levels off. After this, it stays constant at 4.4. It stays constant, it levels off and stays constant. This is a description for the question. Glucose increases from 0.5 to 2. The rate of CO2 increases per minute and then it levels off. Estimate the concentration of glucose the scientists use to test their method using your answer in 1 CI. We said here that he tried the method using 1 glucose concentration, but he didn't give you this concentration. However, he told you that the experiment gave out 2.7 carbon dioxide per minute. So from your graph, you can get the glucose concentration. You will reach the 2.7 point, which is the carbon dioxide, and then move until you meet your graph and go down. This line could vary slightly between the people, between your answers. It's because it's according to the line drawn. As long as you read the number correct from your graph, you will have the correct answer. For me here, it's 1 box after the 1, so it gave me 1.05. 1.05. How the student could show that glucose is used in this investigation is a simple sugar. You will carry out a simple Benedict test. Add Benedict reagent, heat in water bath. Color will change to orange-red if there is glucose. What is the hazard when testing for reducing sugar? Either you can write that using the Benedict, which can splash into your eyes and damage your eyes, so you have to wear goggles, or the heating process, so you have to use a test tube holder. Heating, use a test tube holder. Okay, this is the first question. The second question, which Astronella, which are microscopic algae that lives in fresh water. He asked you to draw this algae. How am I going to draw it? You can draw guidelines for yourself. Like here we have 1, 2, 3, 4. So if you want to draw it accurately, you will draw 1, 2, 3, 4. And then you will draw the rods around it, long, a bit rectangular rods, 8 rods. It has to be the same number. Okay. After you draw the rods, you will erase the lines. Please, when you draw the lines that guides you, make it with the pencil and very lightly so you can erase it easily. Okay? And then I will erase the lines in the middle. And then you will draw the circle. This is how you draw this drawing. It doesn't need labels. It doesn't need anything. Just the 8 rods. Measure the length of the line AB, include the unit he gave you on the figure, the AB. You will measure it using your ruler and you will include the figure. It is in centimeters using your ruler. Multiply by 10 to change it to millimeter. Preferably in paper 6 we use millimeters, so we multiply by 10. It will give you 85 millimeters. Use the formula to calculate the actual diameter. Whenever I see a question about the magnification, I put my triangle, magnification equals image over actual. If I want the actual diameter, then I will put image over magnification. The image is 85, the magnification is always under the picture, 425. So 85 over 425, it will give me 0.2, and don't forget please to put the unit, 0.2 millimeters. The last question here, design the experiment. The algae photosynthesize. This process uses carbon dioxide. We put hydrogen carbonate indicator to determine the concentration of carbon dioxide. And he gave you the results. If there is low carbon dioxide, color will be purple. If there is medium, it will be red. If there is high, it will be yellow. A student used the hydrogen carbonate indicator to investigate the effect of light intensity on photosynthesis. Of course, when the plant photosynthesize, it will absorb the carbon dioxide. So the carbon dioxide will decrease and it will give the color purple. This is what I'm going to do. The changed variable here is the light intensity. He wants you to change the light intensity. So describe how the student could carry out this experiment. First of all, how many plants are you going to get? How many algae? I'm going to use 5 algae. Okay. And then what am I going to change? What is the independent variable? The light intensity. Put each in a different light intensity. How am I going to do this? By changing the distance of a lamp. Putting the lamp close by and then pulling it far away. Different distances. Put each at different light intensity by changing the distance of the lamp. What are the controlled variables? Any other variables should be the same. The type of algae, the temperature, the speed, the mass of the algae, okay? The volume of the hydrogen carbonate, anything else should be the same. Okay, what am I going to record as my results? Record the time taken for the color to change to purple. Makes sense because when it photosynthesizes quickly, when there is a lot of light, it will make faster photosynthesis. So it will absorb all the carbon dioxide, CO2 will decrease, and color will change to purple. As a safety, as an improvement for this experiment, I can put a heat filter because the heat filter um, allows the light to pass and prevents the heat from passing. So the lamp will produce heat and light. So the heat filter will allow the light only to pass to affect the experiment, but the temperature will not pass. At the end, we tell him to repeat the experiment at least 3 times and calculate the average. Okay. The last question here, he asked me to name another pH indicator. I can say litmus paper, universal indicator, whatever. And this is it.